Well, you have a
That's cool.
What do you have?
I took pre-calculus.
No, a B? You just lied. A B? I can
If
tell
you're
you
really
lied.
savvy, you can actually use pre-calculus to solve calculus
No,
exercises.
you're like this fucking. I can't
Really
remember.
savvy. Learn your
Say
pre-calculus
you,
well.
Pinocchio.
No, that's
You said that I was big nose. I said, okay, Pinocchio.
okay. So we're getting good progress in the
That was
front
a good
two
one.
rows. Back rows having a dragging their feet a little bit. Third rows.
Turn to the side. Let me see that. Cannon. Have a side flip out. Let me see.
Will you be doing any chemistry today?
Oh, we already did it. Oh,
You did all those already?
do we have to write them down?
Yes.
We talked about them.
You have confirmation bias if you don't write them down. You'll be like, boron trifluoride. Did I get that right? Yeah, I'm smart. I got that right.
Yeah, but was that not the answer? Carbon monoxide, carbon dioxide, boron, trifluoride, carbon,
Well, I have a fun activity. Alexa,
diphosphorus.
what is the chemical name of N3O5?
Oxide, nitrogen, dioxide, dinitrogen, tetroxide.
Alexa, what is the chemical formula of dinitrogen tetraoxide?
Nitrogen dioxide's chemical symbol is NO2.
Emma.
Technology.
See, this is why I need to work part-time for Amazon. We can improve it. I know how. I know how we can make Alexa better. Chemistry. No buds in class, please. All you people have hoods over your face so I can't see your buds. Okay, no buds, good. I know you can't go more than a few minutes without the beads, but
6 for 5.
yeah.
Earbuds in. Oh, God. Can I have some cigarette?
So
No, I put it down.
I have a
this
Oh, yeah. So, you know, I did get
the O2 minus is a special kind of ion called peroxide. And this is actually one of those almost like right in the middle between ionic and covalent. So that's why I say oxide.
Kenny, you're supposed to be writing these down.
Okay, so it sounds like most of you have got almost all of them. Take another minute and then we will reveal the answers to our mysteries.
You don't know. Nothing. You're right, I know. Actually, I do. It looks like your face had a chemical reaction. Bubble from it. You're running. So rude. I'm pissed at you, Ken. I said he's basically a chemical reaction.
Oh no, it's not raining. Barely raining.
I know.
It's raining until Thursday. Penta.
It's been getting better. Yeah,
Like a
and a smaller
pentagon.
day. Beat that.
Or the pentagon. You know, like if you make a pentagon, or you build a pentagon, or you go to the Pentagon. All right. So these guys we've already done. So what's this? Yeah, everybody. What's this? Carbon monoxide. This one.
Carbon dioxide.
Carbon dioxide. This one.
Boron trifluoride.
Boron trifluoride. This one.
Carbon tetrachloride.
Carbon tetrachloride. Now here, this is not a 1, so we do need to say what this is. What is this?
Diphosphorus pentaoxide.
Good. Diphosphorus pentaoxide,
Nitrogen dioxide.
nitrogen dioxide,
Dinitrogen tetroxide.
dinitrogen tetraoxide,
Trinitrogen pentaoxide.
trinitrogen pentaoxide,
Dihydrogen oxide.
dihydrogen monoxide. Dihydrogen monoxide, Gesundheit. Like that dude 20 years ago tried to get dihydrogen monoxide outlawed. Because if you breathe just a small amount of it, your lungs will spasm and you can die.
Where can I get this stuff?
Drink the
This stuff's everywhere. It's falling from the sky right now.
But is that not H2O?
Yes. Dihydrogen monoxide. Okay, what's this? Sulfur dibromide, silicon dioxide, and
Phosphorus trichloride.
phosphorus
I have a
trichloride.
question.
Okay, questions?
So that's not water.
It is water.
Wait, so then if you breathe it, you're dead?
Yes.
Have you ever tried
Your lungs don't like to breathe water.
I mean, I was thinking like a gas.
Okay, so have we mastered level 2? Okay. There's only 2 levels left.
Wait, what?
Have we mastered level 2? We mastered metal, non-metal, potassium chloride, and we mastered non-metal, non-metal, diphosphorus pentaoxide. Now, level 3. I told you last month to skip over the oxidations of the D block metals. So we go +1, +2, +3, +4, -3, -2, -1, 0. I told you that last year, or last month, right?
Yes.
The reason I told you to skip over the D block is because they are you ready for this?
No.
Multivalent.
Oh.
Meaning they can have multiple valence electrons and have multiple oxidations. So if you write a chemical like this, Fe2O3, this is iron 3 oxide. Are you paying attention?
Yeah.
So on your crossword, Fe2O3 was iron 3 oxide. Now you might be tempted to say, oh, the 3 means how many oxygens you have. And honestly, that's the biggest hang up a lot of us have with D block, is we see this 3 and say, oh, that means there's 3 oxygens. That's not what it means. What it means is this iron is a +3 iron.
Oh.
Okay? That's what iron 3 oxide means. It means that iron is a +3 iron. It's the kind of iron that makes red rust. Okay? When iron is +3, it makes red or dark orange ions. Does that make sense, what I just said?
Yes.
Question? Yes. Make sure you put your foot in the box. Now, on the other hand, if you have, let's use black, because it's black. If you have iron oxide, this is iron 2 oxide. And this iron 2 tells you that this iron is a +2 iron. Iron 2, the name tells us, and the formula, I'll get to that. Iron 2 makes black compounds. Okay, so we use a D block, when we have a D block metal, we use a Roman numeral to tell us what that D block metal is. Which metal is it? Is it iron 2 or iron 3? Is it cobalt 3 or cobalt 6? Is it tin 4 or tin 2? Is it chromium 6 or chromium 1? Does that make sense? We'd write them like this. So if you have a D block metal, and only D block metals, you have to tell the reader what D block metal you have.
So how do you figure out the charge for like it being like Fe2O3? How did you get the 3s come out of that since it has the Oh my god.
So the question was, how do I know what the 3 was? How do I get the charge? And I'll tell you that once I see pens go down to people done writing, or phones go down so they're done taking pictures. And I'll basically show you probably the only mentally challenging part of this unit. And it's basic arithmetic. So, but I'll show you that in a little bit. Okay, so the D block metals can be anything from +1 to +7. You don't know, if I said, give me some copper nitrate, you don't know which copper I want. I might want copper 1 nitrate, I might want copper 2 nitrate, you don't know. So you have to say, which copper do you want? Now, here's the thing, to Matthew's question. How do I know what the charge is? And here is the most important thing. The overall oxidation of any compound has to be 0. The overall oxidation of any compound has to be 0. If it isn't 0, you can't hold it. Okay? If it isn't 0, it doesn't exist outside of a plasma or a molten state or a water state. You can't hold it. So like, yeah, I'll get to that in a second. So what this means, oxygen. Oxygen is almost always the same charge. If you find oxygen on the periodic table, look at the giant green blob up there. Never had a laser get this out of focus. I must have dropped this a lot. So oxygen right here is sitting in group 16. How many valence electrons does oxygen have? 6. How many does it want?
2.
It wants 8 to get 2 more. So oxygen's going to be a -2 charge. Oxygen's going to be, brains back, -2 charge. How many oxygens are present here?
3.
3. -2, -2, -2. Even I can do that math. How much minusness is in this compound? It's -6. There's a -6 anion side, which means the cation side must be, what? If the anion side is -6, the cation side must be +6. Which means that iron, each iron has to be what? +3. The overall, listen carefully, the overall oxidation of any compound must be 0. Otherwise, it can't be a compound. If it exists, it has an overall oxidation of 0. We know oxygen is -2. And how many oxygens are there? 3. -2, -2, -2, for a grand total of -6. Cool? If the anion side is -6, that means the positive side must be +6. How many irons make up the +6? 2. So let's just take math out of it entirely and let's make a little box. Okay. Equal sign. The left box has to equal the right box. Cool?
Yes.
So if the right box has -2s, in this case, let's just go ahead and just keep it the same system. If it has 3 -2s, your options for the left box are what? Yeah. A single +6, 2 +3s, or 3 +2s. Okay, so those are your options, right?
Yes.
So that's how a compound works. Whatever you have on the anion side has to match the cation side. And the cation side has to match. The overall thing has to be 0. So look at the iron 2 oxide. This thing has to be 0. Oxygen's -2, iron is +2. Make sense? That's why it's iron 2 oxide. Cool?
Yeah.
Okay, so that's level 3. and we're going to do a bunch of practice, I promise, later. So, you don't need to do this because, again, I think we've transcended this, but this is vanadium. How do you draw a 4?
V or IV?
IV. So, IV, this is copper II, this is lead 2, Pb 2+, this is nickel 4+, and this is cobalt 6+. So, you would write it like this. Vanadium IV. Copper II. Laura, are you using your phone as a tool or a toy?
A tool. I was printing out my pictures.
Printing out your pictures?
No, I was like, I had to type my password to get my pictures.
Got it, okay. So this would be, lead 2 would be Pb 2+. Nickel 4 would be Ni 4+. Cobalt 6 would be, well, this. It would be that. Okay. Make sense so far? Yeah. All right. Perfect timing. Okay. So if you like oxygen, if you like examples, here you go. Remember how I said the oxidation states don't matter for covalently bonded compounds? I do this just as an example, just to see it's always equal to 0. So oxidation must be 0. Okay, next. Pure iron. Does pure iron exist?
No. No.
So those pots that you get, the sizzling skillets that are pure iron, those don't really exist at Applebee's?
Oh, okay, so yes.
Yes, pure iron does exist. Remember what I said about something that exists? What is the oxidation of something that exists? 0. So if an element exists, and we know pure iron does exist, then pure iron has to have an oxidation of 0. This gas that's keeping you alive, what's the oxidation of oxygen? 0. If the see, you're not paying attention and you're doing other things. If the oxidation of something that exists has to be 0, and we're all breathing oxygen, then the oxidation of the oxygen molecule must be 0. See how that works? And if I handed you aluminum, like here's some aluminum. So if I came by and whacked you with my aluminum bar, you're like, ow, was that pure aluminum? I was like, yeah. Oh, that aluminum must have an oxidation of 0 because it exists.
Can you move that? Wait, what? Does that?
Lighter than that.
Yeah, that sounds so stupid. Does that mean there's like other stuff in like aluminum to make it all?
We can get that sewage money.
No, it's just very, very thin.
Okay.
If you were to take a saw and grind this down to aluminum foil thickness, it would go blue.
Oh, okay.
Wait, that's kind of cool. Can we do that?
No. Well, I guess you could probably do it in robotics. They have those tools. Argon. What's the oxidation of argon? 0. Because we know argon exists.
Yes.
Okay. What I'd like you to do now, and we'll just wrap up right here. What I'd like you to do is determine what the oxidations of each of these things are. And I colored them sideways. You can see that there's definitely that. Remember binary? This is not silver chlorine iodine. This is silver chloride, silver 1 chloride. So if what I'd like you to do is on your paper, determine what the oxidation of each of those 9, 10, 11 things. Each of those 11 things. Can you press the button, please?
Oh, yeah. So basically, if it's